Alright, so what we want to do next is solve absolute value inequalities. Again, let me remind you that you can solve these using what we learned in 5.6. I kind of technically think that's easier, but you can use what I'm going to teach you right now. So what happens in 1.7 is we basically use, dare I say, kind of like a characteristic or a property of absolute values to help us out. So let's go back and remember, I think this was 1.3 or 1.2. When we were solving an absolute value, let's just do a real simple one, right? When does the absolute value of x equal 3, right? We found that there were two answers here, right? Because again, we're talking about visually, right? How far am I? Here's 0. And I want to know, right, when am I at a distance of 3 from 0? Well, that happens at -3, and that happens at +3, right? And so those were our two solutions to that inequality. And we actually used that to our advantage when we solved inequalities. So what happens when we change this and we talk about the absolute value actually being less than 3? Well, again, we're talking about the distance from 0. So if I look at this, right, we're talking about -3 to 3 again, and I want my distance from 0 to be less than 3. Well, that would basically consider that whole thing in here, right? These are all the x values whose distance from 0 are less than 3 units away. And so basically what we do is we take this, if we have a less than statement, we basically convert that to the compound, let me make that a little clearer. We convert it to the compound inequality where we have an and statement. All right, so saying that the absolute value of x is less than 3 converts to the compound statement where our x, right, is between -3 and 3. And so we basically would solve that inequality, as you'll see here coming up. And of course the other nuance is what happens if the absolute value is greater than 3. Well, on a number line, again, here's -3 and 3, there's 0. My distance from 0 has to be greater than 3. Well, that puts me here, or that puts me here. So we're talking about x being less than -3, or x being greater than +3. And so that is the strategy we're going to use to solve an inequality. We're going to rewrite them. So if we have a less than, we rewrite them as a nice, my number sits between the opposite and the positive of the number that's given. If we have a greater than, we're talking about numbers that are less than its negative or numbers that are greater than that's positive. So we basically go through a rewrite to do that. That requires you to remember some stuff, which is why I like the idea in 5.6. You just remember how to solve an inequality and then plug some numbers in and you got it. So choice is obviously yours. So there's some groundwork. So let's go ahead and solve some inequalities here. So the first one, right, I've got the absolute value of 3x minus 4 is greater than or equal to 2. All right, so that is this category here. So my rewrite, I have to have 3x minus 4 less than or equal to -2, or 3x minus 4 is greater than or equal to 2. All right, and so that's basically, I'm rewriting it. Except rather than having a nice neat x in the absolute value, I have the expression 3x minus 4, but it's the same thing. So we basically solve this. So adding 4 to both sides, right, we get 3x is less than or equal to +2. Dividing by 3, we get x is less than or equal to 2/3. Or if I solve this one, we get 3x is greater than or equal to 6. Dividing by 3, we get x is greater than or equal to 2. So inequality-wise, we're talking about -infinity to 2/3, union 2 to infinity. So there would be this inequality, right, and that interval notation match, and that inequality and that interval notation match. So we basically have our work. And I forgot, I just realized I didn't load this up. So let me load this up on my we got 2, and we got -2, and then my graph is the absolute value of 3x minus 4. All right, so when I go graph this, right? Here's the graph. So in red, right, is our graph of our absolute value. All right, and you can see that absolute value, right, it's bigger than 2, right, it's larger than 2, right, starting at that value, which we know to be 2/3, and to its left, right, it's greater than 2, starting at 2, and going everything to its left. So again, there's y equals 2, and there's the absolute value. So we can see that it is actually, the graph of the absolute value is larger than 2, right, for the exact intervals that we said it's going to happen. So that tells me my math is on the right track. All right, and then the next one, same thing. We're solving a greater than, so that means we have this situation again. So 1/2 x minus 2 is less than -4, or 1/2 x minus 2 is greater than 4. And then we just basically solve the linear inequality. So adding 2 to both sides, we get 1/2 x is less than -2, and multiplying both sides by 2, we get x is less than -4. And again, I don't have to, it's just coincidence that we started with -4 and ended with -4, so don't read too much into that. But I don't have to flip-flop this inequality because I never ever multiply or divide by a negative. Over here we'll add by 2, we get 1/2 x is greater than 6, multiplying by 2, we get x is greater than 12. So we have -infinity to -4, right? Union, and as a matter of fact, it's a strict inequality, so that's why I'm using parentheses. Union 12 to infinity. And so again, I should have preloaded this, but let me go ahead and get that done. So here's 4, and let's change that inequality. We have 1/2, take away 2. All right, so when I go graph this, right, there's basically the graph of this situation. So what's in blue, or excuse me, what's in green is y equals 4. And we can see that the graph of the absolute value is above that line. We know that to be -4, right? So if I right? So that's at -4, so we can see that the absolute value graph is above it, just as predicted. And then over here, dang it, over here at 12, right, the graph of the absolute value is above the line, just as we predicted. So again, my algebra and my graphs are corresponding with each other. I've got a couple more to do, and let me go ahead and get those preloaded in my Desmo so I'm not wasting so much time. But we're almost 8 minutes into this, so let me pause and I'll finish up our absolute value discussion, these last two, in a video coming soon.